start. We are going to start. Hello, Lian. Hello, Iris. Shoye. Sudashri, everybody's coming back. I'm trying to use my skills to get everybody come back. So we are going to start again. Welcome back to the participants online. Thank you for being with us, being so patient. And we are going to start again with Alex, Prof. Cavalcante.
Very good.
Who is going now to torture you. Okay, welcome, Alex.
Thank you. Thank you. Can you guys hear me? Yes. This is not a presentation. This is an activity for all of you who love mathematics, just like me. Magic, MGMT, dice. I'm just getting one link to show to our participants on Zoom. So just bear with me. For those who are here on Zoom, I'm going to share a link that you can use as a manipulative for this activity. For those who are in person, I'm going to ask, Sarah, can you help me? So I want you all to sit with a partner, okay? This activity is not meant to be done individually. Please find your neighbor, find one partner, and work with them. Zara, hello. Zara will give 2 dice each pair, okay? 2 dice for each pair. And let's see, thank you. One small piece of paper that you can work with along with your partner. While they are sharing this, let me just share my screen with you all. Let me see if it works. Can you all see my screen? Okay, so let me explain. Yes, I can share the link one more time on Zoom. Here's the link for those who are on Zoom. Now, the activity that I have prepared is one activity that I do with my own students in my course. So you are all pre-service teachers right now, ready to teach grade 12 mathematics. How exciting is that? The reason why I decided to share this activity with you is because I believe throughout this conference and throughout the experience of the SCAPE projects, I feel like we focused a lot on the language differences that happen in mathematics and science. And sometimes we tend to forget the things that are common to all of us. For example, using dice, right? Many cultures in many different types of contexts, we use dice to play games, thank you, Zara. Did you get one yourself? Okay. You don't have it? Okay, so in many situations, we take for granted these kinds of activities, these kinds of things these kinds of objects that we can use in everyday life. So can a few people please share with us different types of activities or different types of games that you use dice in your childhood or with your children? What kinds of games do you use what types of games require you to use dice? Yes, Zara? Sorry? Snakes and ladder. Okay, I remember this game. Monopoly. I have actually one game that's called Canadopoly, which is all about Canada. Monopoly as well. What else? Ludo? Okay, I don't think I know this game yet. What is the name in Arabic? Huh? Tal, Zaha. Okay, it's a board game. Okay, I will search later if I can remember. It's like a chess. Okay. So in many of these situations, you're using dice to throw and find the fate of your character in the game or your fate in the game based on the results of the dice, right? In math classes, a lot of teachers, they also use these kinds of dice because they have a certain geometry, right? And because of these types of geometry, you can have probabilistic events such as what is the probability of getting 1 out of 6, or what is the probability of getting 6 out of all of these dice. In many of these cases, we only focus on one of the results. So I throw the dice, I got 6 in my top face, and I don't care about any of the other faces. I also, in my experience, this is how I've been playing dice as well. And I play dice as Lord Zender of Brasilia because I play Dungeons and Dragons. I don't know how many of you know Dungeons and Dragons. It's a game that takes awfully too long. It's been 3 years that I've been playing the same campaign, the same narrative with my friends. I don't actually enjoy very much every time we play it because it's been 3 years. But it's nice to see that not only you can throw the dice and get the results, but there are also different types of dice. I don't know how many of you are familiar, but for example, this is called a D20. It's a dice with 20 different faces. Another type of dice that I have here is the D12. It has 12 different faces. But in many of these situations, we don't actually explore too much of what a dice is, what a dice does. So let me just change here to presenter mode. For this activity, you received a piece of paper and you're gonna work with your partner. And every time you notice something in the activity that you're doing, or you're wondering whether what you're noticing is actually real or not, I want you to take a note, okay? Some of you might have pens, you can write it down. Here's what I want you to do. With your partner, you're gonna roll a D6. The dice that you received is a D6 because it has 6 faces, okay? So each pair has 2 dice, right? Am I correct? Yes, so throw 2 of them. Don't throw on the floor like I just did. Throw 2 of them and mark the results according to this table. One of your dice would be A, the other is B. And I want you to write it down. I want you to write it down, the number that you see on the top face, but also on the bottom face. You see, when you throw the dice, one of the faces is facing up, which is the top. Another one is hidden down there. It's the bottom face, okay? I'm gonna give you a few seconds to do that. The 2 dice, throw once, and then you're gonna get 2 results. Each one of you has a different piece of paper, right? So you can try twice as well if you want. 2 dice. Or you can throw twice with your pair. Okay, okay. Have you thrown your dice yet? Yes. You can use the first table, which is called D6 table, right? Okay. Okay, let's pause. Pause. Everybody looking at me? Can I get some examples of results that you threw? Dania. So Dania got 6 and 1, and then 3 and 4. Okay, anyone else got a different result? Yes? So 2 and 5, and 5 and 2. Okay, interesting. Any other result? One more result, Rosalia? 5, 2, 6, 1. Okay, now in your piece of paper, you will see that I'm asking you to calculate a few multiplications, right? A few products. The 2 tops, write down the number. The 2 bottoms, write down the number. And then top, bottom, and bottom, top. So calculate these products and add them all together, okay? And the reason why I'm telling you to work with a partner is so that you can all verify each other's calculations. Some patterns are emerging. Okay, verify with her the results. Once you have your results, can I see some thumbs up? Okay, I see some thumbs up. Okay, a few more minutes. Yeah. And one for you guys. Thank you. Oh, okay. We're all ready to share some of our findings. Can anybody share with me what they found after adding up all of these products? 49, everyone got 49. Wow, I wonder why. Now, take the D6, look at the bottom and the top face. Look at your D6, look at the bottom and the top. 2, 5. Now, look at different faces, bottom and top again. 3 and 4. 1 and 6. What do you notice? They always add up to 7. A difference of 2. Yes, there's a difference of 2. Now, I gave all of the pairs a different type of dice, didn't I? Now, observe the geometry of this dice together with your partner. See if the same pattern emerges in these dice. Bottom and top adds up to how much? Check with your partner. Okay, check the other faces now. Okay, what did you notice from the dice that I gave you? 13. And what type of dice did I give for those who add up to 13? It's a D12. For those whom I gave the D20, how much it adds up to? 21. Okay. We don't have as much time to do what I do with my students, but these kinds of patterns is the kind of exploration that students can do in mathematics. What's interesting is that not only you're using an object that is actually something that unites all of these different languages that appear in the classroom, but the ways to approach or the ways to explore whether this is true or not, you're all made conjectures today. All these dice add up to a certain number. All of these products add up to a certain number. But in mathematics, in order to verify if things are true, you actually need to explore. You can explore in mathematics by doing experiments. You can throw these dice infinitely. You can create programs in Python to generate these simulations. You can check all possible combinations. So in your D6, you can just look at those 3 pairs of faces, right? It would be very easy. But if you had a D100, which is a dice that exists, it would be a little bit more complicated. Or by studying the geometry of these dice, you can actually create an algebraic proof that shows that whatever conclusion you guys arrived at, it is true. If all of the faces add up to 7, once you calculate all of these products and sum them up together, it adds up to 49. So all of you guys were correct. And for those of you who are elementary teachers, do I have elementary teachers in the room? Okay, quite a few. We do have elementary level teachers. This can be explored through something that is called the area model of multiplication, which also ties to the transition to algebra using algebra tiles in your classes. Now, every time you look at a dice, you're gonna remember me. And you're gonna remember the geometry and the mathematics of a dice, not simply the monopoly aspect of it. Thank you very much. And let me just say, I apologize for people who are on Zoom. I unfortunately neglected those of you who are there, and I apologize for that. Please do not steal my dice. Please return them to the boxes.
Thank you, Alex, for giving the tone of the afternoon.